Hey guys, I hope you're doing well. Today we are going to review the pH calculations and go over neutralization reactions, which is something kind of old and kind of new. So you should have your periodic table out and then just your calculator for the first little bit. I want to make sure you're typing things in correct. To review, this was from last week. So acids have a pH less than 7. They have more hydrogen ions than hydroxide ions. Some examples. If a solution is neutral, the pH is exactly 7, which means the amount of hydrogen ions equals hydroxide. If it's like 7.01, that's a base. 6.99999 is an acid. Only 7.00000 is neutral. And then bases have a pH greater than 7, and they have more hydroxide than hydrogen. Okay. And then to calculate pH, this is a very common formula. If you don't know where the log button is on your calculator, it's right there under second. And make sure you're using the negative symbol, not the minus symbol, because that will give you an error. Yep. And so when we're given H plus to calculate pH, we use this formula. If I've given OH, you're going to calculate POH using this formula. And this is where, I know we're online and it might seem weird, get paper out and write your work down and write what it equals, because it's really easy to, I give you the OH, you do negative log that thing, and then you're like, the answer's 6. So like, oh, the pH is 6, it's an acid. No, you were solving for POH. So I really suggest you write down things like if POH is 6, then pH is 8, and it's a base. Write things down when you're doing these calculations. It helps. And we're just going to do a few practice ones. So what's the pH of a solution where OH equals 1 times 10 to the negative 10 molarity? So I've given you OH. So we'll use this formula first to solve for POH. Negative log, type in the whole number, and POH equals 10. And that's POH. But I asked about pH. pH plus POH always equals 14, so our pH is 4. That would be the final answer. But I'm telling you right now, on the test, another answer choice would be 10. And probably half of you would pick 10. You have to be careful, and please, please, please label it like this so you don't get yourself confused. And then, is this an acid, base, or neutral? Well, it has a pH of 4, so it is a acid. What is the pH and POH of a solution with H plus equals 1 times 10 to the negative 3 molarity, acidic, basic, or neutral? Well, I've given you H plus, so we'll find pH first. Negative log of H plus. And type that in. Our pH equals 3. pH plus POH equals 14. So our POH is 11. And then the last part of the question, is it acidic, basic, or neutral? pH is 3. So it is acidic. Okay, moving on to new stuff. Neutralization reactions. A neutralization reaction is when you react an acid and a base together and they always produce water and a salt. And these are really just double replacement reactions. That's why I said it's like kind of old stuff. And what is a salt? A salt's an ionic compound. But when you mix an acid and a base, and these are all going to be acids that start with H and bases that have OH on them, we're not going to do Bronsted-Lowry. Those are always the products, water and something ionic. And so looking at these two examples, HCl, acid, plus NaOH makes NaCl plus H2O. Now, do you remember I told you a while ago to write water as HOH? I did that because when we look at this reaction, now it's going to be kind of hard for me to write. Do you remember what double replacement reactions I would tell you? Underline like the first one here. So this H goes with the OH, and that's how we get water. And then Na is going to go with the Cl. They go together. The outsides go together and the insides go together to give you your product. And looking at the next one, HBr plus KOH. First one goes with the outside, and then the insides go together. And so it becomes water and KBr. And so using this template, we're just going to do another example. Let's say we'll do a lot more examples in a minute, but we've got some more stuff to label. Let's do hydrosulfuric acid plus KOH. And what would that make? So I want you to still do the underline thingy like I taught you. H is going to go with the OH, so we get water. And then these two go together. Now, with double replacement reactions, you have to think about charges before you write a product. Potassium, and so you might want to write charges up above. Potassium is a +1. Sulfur is a -2. And so that's K2S. And then, is our reaction balanced? No, it's not balanced. And I'm going to change pen color. I've got 2 potassiums on the right, 1 on the left. So I'll put a 2 right here. And then now I've got 2 oxygens and then a total of 4 hydrogens on the left. So in front of water, I'll write a 2. You still are going to have to balance equations. Sorry. Now, our salts. Our salts can be acidic, basic, or neutral. It just depends on the acid and the base. So if a strong acid is mixed with a strong base, then our salt is neutral. If a strong acid is mixed with a weak base, then the salt is acidic. Makes sense? And if a weak acid is mixed with a strong base, the salt is basic. These 3 rules we do need to know. Now, you're not going to have a weak acid and a weak base together. That isn't an option, so don't worry about that. But make sure you know these 3 because you are going to have to label or write them down if your salt is acidic, basic, or neutral. And you just tell off this list, which, okay, what's a strong acid? These are strong acids. These are the 6 strong acids: hydrochloric, hydrobromic, hydroiodoic, nitric, sulfuric, perchloric. If it's not one of those, it's a weak acid. And then strong bases are group 1 and group 2 metals. What do you mean group 1 and group 2? From the periodic table, like column 1 and column 2. So KOH, K is in group 1, it's a strong base. Calcium hydroxide, CaOH2. That's from group 2, calcium's from group 2, so it's a strong base. Silver hydroxide, silver's not from group 1 or group 2, so it's a weak base. In group 1 and group 2, those are columns. So those first 2 columns are strong bases. Write these down, make sure you know these, because that is how you'll figure out what your salt is, and I will most definitely ask you about them. And so we're going to do some example reactions. We have sulfuric acid plus KOH. So first we're going to write our products balance our equations, and then determine what the salt is. This is what you're doing on your worksheet tomorrow. Okay, so first writing our products. I'm going to underline the outsides, HOH, go together, and then K goes with the inside of this, so the sulfate. Now really fast, think about charges. Potassium is a +1, sulfate is a -2, and that's supposed to be a 2. And so that is K2SO4. Part 1 done. Now we need to balance our equation. 2 potassiums on the right, 1 on the left, put a 2 in front right here, and then now I've got 4 hydrogens on the left, 2 oxygens, so a 2 in front of the water. It's balanced. Now we're going to figure out what is the salt. And so looking at our list, sulfuric acid is a strong acid. Potassium hydroxide, what group is potassium in? Go to your periodic table. Potassium's in group 1, that's a strong base. And then going up, looking at the rules, strong acid plus strong base means this is a neutral salt. They cancel out, they're equally strong. And this is what you're going to do tomorrow on the worksheet. Another example, H2S plus NaOH. First, we're going to write our products. H goes with OH. And I don't really care if you write HOH or H2O, it doesn't matter. And then the insides go together, Na and S. Thinking about charges, sodium's a +1, sulfur's a 2-, so our salt is Na2S. And then balance our equation. And I forgot to erase that coefficient. Obviously, that's why it's there, because we need a 2 in front of that, and we'll need a 2 in front of water. And then figure out what the salt is. Go to your list. Hydrosulfuric acid, is it on the list of strong acids? No, it's not. It's a weak acid. NaOH, strong acid or strong base? Where's sodium? Sodium is in group 1 because it has a charge of 1. It's a strong base. So my salt is weak acid plus strong base. It's a basic salt. Perfect. And one more example, and then there is something else after this, so don't go away. H2SO4 plus NH4OH ammonium hydroxide. Oh, and I started to balance it for you already. Okay. Writing our products. H goes with OH. HOH plus the insides go together. Sulfate and ammonium. Now, ammonium is NH4 +1. Sulfate is 2-, but that NH4 is a polyatomic, and we need 2 of them to cancel the charges out. And so that formula is NH4 2SO4. And then I didn't erase the coefficient. It's already started to be balanced. There's a 2 here, so there's a 2 over here, and then we need a 2 in front of the water. And to figure out what type of salt this is, sulfuric acid, H2SO4. Is it on our list? It is. It is a strong acid. NH4OH is NH4 in group 1. Hydrogen's in group 1, but the N isn't, and it's a polyatomic, so no, it's not a group 1, it's a weak base. which means strong acid, weak base. This is a acidic salt. And tomorrow on your worksheet, this is all you're going to do. Write your products, balance, determine what the salt is. And you determine what the salt is, acidic, basic, or neutral, based off the acid and base. And you just have to look at your list and remember the rule: strong acid, weak base, acidic, salt. Strong, strong, neutral. Strong base, weak acid, basic salt. And moving on really fast. Indicators. Indicators we would be using in lots of labs if we were at school, but we're not. So indicators, these are just chemicals that change color in the presence of an acid or a base. They don't change the pH or the solution at all. All they literally do is just change color, like food coloring. And there are a lot of indicators. These are just some common ones. That big long word, phenolphthalein, you don't need to know these. There's a universal indicator, bromothiol blue, methyl red. They're just like food coloring, except they change like one color if it's an acid, one color if it's a base. And they're really important when you're doing labs with acids and bases, because if you mess up and you make something like more acidic and it shouldn't be, you can tell because of the color change. And a titration, we would be doing a lot of these if we were at school. Unfortunately, we're not. Like, we do 3 or 4 labs with titrations. And so this little setup is what a titration is. And it's a method in which a standard solution is used to determine the concentration of an unknown solution. So pretty much what happens is this solution right here, I pour it into the top of, this is called a burette. I pour it in up here. I know what it is. Let's say it's like 1M in AOH. And then this little flask will actually be over here underneath, and that's like something unknown. It's an acid. And so what happens is you pour the base into this burette, and this little thingy, it will drop the base into the acid. It will go down, and this has measurements so you can know how much base is being added, and when eventually the color will change because you've added an indicator to it, and that tells you it's got a neutral pH. And when the color changes, that's called the equivalence point. It's the point where the amount of hydrogen and hydroxide ions are equal, where the pH is 7. And it's actually really fun in class because you got to get it like a super light pink. So you either add an acid to a base or a base to an acid, it doesn't really matter, but it trickles down out of here into the solution. You stir it, and it continuously gets added until the color change happens. And when the color change happens, the pH is 7, or those are equal. And then there's lots of calculations you can do. We're not going to do them because they're really hard to teach online, and so we're just throwing those out. But you could figure out like what your acid was, how strong your acid was, based on how much base you added. So titration, you add a solution to another solution until the color change happens. And the color change happens because there's an indicator in there. That indicator is phenolphthalein, and it turns a light pink at a pH of 7. And then once it's a base, it's like hot pink. So you know if you added too much, because the solution will go light pink to hot pink. And here's just another little picture of it. So the burette solution goes into the flask until there is a color change because you threw an indicator into the flask. Now you do need to go watch the titration video in Canvas because it's not going to let you move on to tomorrow's assignment until you watch the video in Canvas. So make sure you go watch it. It will explain titrations just a little more in depth.